Hello everyone, welcome to this tutorial. My name is Emerson Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to calculate number of dust events using MODIS aerosol product. So, first of all, you must select your region of interest. For example, I'm going to select a region in my own country, Iran, that always suffered from dust storms that's coming from external sources in the Middle Eastern country or sometimes from the north of Africa. So here, my study area located in the southwest of Iran. You can select your region of interest through the drawing tools available here. For example, using rectangle, I'm selecting a part of this area that always suffered from external dust sources coming to inside the country. So first of all, use map.center object to have focus on the study area as a geometry. In the next step, you need a variable to call MODIS AOD product. Go to the search places on dataset, and as you can see here, just type MODIS aerosol optical depths. As you know, AOD stands for aerosol optical depths. This is one of the typical measurements from the satellite's observation that is highly correlated with the dust or particles available in the existing particles in the atmosphere. As you can see, the MAYAC product is available, integrated from Terra and Aqua satellite with 1 kilometer spatial resolution, imported into the code. And here you have it as an image collection. Now I'm assigning a imported image collection to the AOD, and then you must define a period of time in which you want to call satellite data. I'm filtering the data based on a time start and time end. Two variables here we have, one for time start and one for time end. Earth Engine date converts the string value to the date format. For example, the start date is 2010 and the end date here another variable, and time start or time end, just like this, equals to Earth Engine date 2011, just like that. Two arguments we should have for the filter date: start equals to time start and equals to time end, just like that. Filter your data based on frames that are covering the region of interest, that is geometry here, as you can see. So in the right panel, for 1 year, we want to get print from AOD data to see how many satellite data or how many AOD product is available for this period of time. It seems more than 5,000 elements is available, and maybe a couple of frames or a couple of tracks covering our region of interest, and that's why we have a large number of satellite data for this period of time. And also we can limit to the first. We can print only first 10 data we have in this collection to have a look on the data characteristic. For each date, as you can see, the AOD, aerosol optical depths, 47 and also the 55 micrometer are available. But if you are working on the urban aerosol, because of the particle size is very small, in that case 47 micrometer is used. But otherwise, if you are working in a non-urban region, in that case, because of the particle sizes is a little larger, we use 55 micrometer. That's why the target band is optical depths 55. Through the select, we can select the target band that is optical depth 55. If you want to check more information about the data characteristic and dataset availability, go to the data link and open it up into a new page to check for more possible information. As you can see, this is the Earth Engine collection. If you go to the bands with 1000 meter or 1 kilometer spatial resolution, this data is available. The target band is optical depth 55 micrometer, and here there is a scale factor 0.001 that should be multiplied on the data. So here we must make a loop structure as a map that goes through all existing elements under an image collection and applies a particular kind of calculation and return the calculated image as a result here. So to do this, we must have a function inside the loop structure. Each input image into a loop structure and function consider it as an ing, or you can pick any other name that you want. Finally, the function returns each input image while it is multiplied to the scale factor that is like that, and with the properties of input images. I want to have all the properties from input to the output. So maybe there is a question here, for example, what is the properties? As you can see, for each satellite data, we have a property, and also if your data prepared in an image collection next to the bands, you will have a property. This is a list of information about the data characteristic, data acquisition, for example, about the kind of satellite data you have. As we are using a combination of Aqua and Terra, the satellites could be Aqua A or Terra T. For example, here we can make a filter about the satellite and filter out data based on the type of satellites we are working. In that case, the number of images reduced, and then you will have a lighter variable from volume. From volume side, you can make lighter code with less volume for the further analysis. So here, make a new filter, EarthEngine.filter.equal. As you can see here, the property is a satellite, and so here the satellite could be A, Aqua, or T. For example, I'm gonna use the Terra satellite data. And now in the right panel here, you can see satellites, and here in the right panel, you can see all the satellite data we have are actually matched with the Terra satellite data, and also all the Aqua data removed after the target filter created. So, and also you can have both of them, Aqua and Terra, higher number of data actually, or higher number of images for the dust monitoring enables you to get more information about the situation in your study area. So now I'm gonna try with the Terra satellite in this step, and then I want to show you about AOD variations during a time. So for example, I'm gonna make a chart here using chart image.series. As you can see, a couple of arguments necessary to have for the AOD chart. Instead of image collection, we have AOD data. The region of interest we want to get AOD values for is the geometry already defined through the rectangle tools. And here we need a statistical operator to aggregate values from the region and show it on the plot. For example, I'm gonna aggregate based on the average or maximum or minimum. The reducers facilitate this process easily. For example, EarthEngine.reducer, that's the aggregator here is the average, meaning that I want to get the average value over the geometry, or I'm gonna get the maximum value over the region of interest. It's totally up to you and the target of your study, but typically we use the average for the spatial aggregation. And the scale here should be 1000 because the spatial resolution is 1 kilometer, and the scale settled based on the meter. That's why we have 1000 meter. X property will be system time start. System time start is a kind of properties here we have that explaining the time the satellite the image acquired by the satellite. So and now run a code in the right panel. After a few moments you will have a chart that shows the number of satellite data that shows the AOD variations for the region of interest. Waiting for a moment. So here, as you can see, more than 5,000 elements we have, and that's why we face with such kind of errors. In case, for example, we can make a daily satellite data or doing mosaic for all the frames to solve this issue. And also because maybe the temporal frequency is higher than daily, or maybe for a day we will have couple of satellite data. In that case, we must make a daily time series to limit our data to 365 elements. So in that case, we must make a list first. I'm gonna make a list of numbers starting from time start to the time end. To do this, here a new variable created as time difference. So I'm gonna calculate the number of the days we have from time start to time end. There is a function in the Earth engine, this is difference, allows you to calculate the differences between time start and time end. So instead of start, we will have the time start, and the units could be anything like minute, hour, day, month, week, or even year. So here, as I'm gonna do the process based on the daily time series analysis, that's why the unit will be day. So print the time difference to see how many satellite data we have, or how many days we have from time start to time end. In the right panel here you can see 365 image available here. And now I'm gonna make a list starting from 0 to 365. So because I'm gonna actually convert the satellite data frequency from, for example, hourly format to the daily one. So here I'm making a list, Earth engine list.sequence. A list of sequence is starting from 0 and ends to the number of days we have, time difference. But as you know, when we start from 0 and end to 365, in that case we will have 366 record in the list. That's why we must subtract time difference from 1 to solve the issue. Yes, and a step will be 1 because we want to have actually 365 with 1 day interval. That's why the step should be 1. So like this, let's print from list just like that. In the right panel, as you can see, we have a list with 365 elements starting from 0 and ending to 364. So here it is. Now I'm gonna replace the number with the date of each day starting from January 1st, 2010 and ends to end of December 2010. To do this, make a function again. As I said, the map is a kind of loop structure that enables you to calculate to do some sort of calculation on each row separately through a function. So here we have the delta, or the day differences, the numbers here we have in the list explaining the differences between the time start and time end. That's why the delta could be a good name for this purpose. And finally, the function returning from time start, I'm gonna have the time start go advance through the advanced function based on a delta, that is number of a day, and the units. The unit could be days. So in this function, as you can see, we will have a date format starting from time start going forward according to the delta already created. So if you run a code again, you will see a list with 365 elements, but in this case, this time you will see that instead of 0, 1, 2, or just a simple numbers, we have the dates, real dates, starting from January 2010 to the December of this year. So in the next step, I'm gonna convert this data from the I'm gonna actually make an image collection to filter the data from time start to time end. So that's why here I'm making AOD collection just like that equals to Earth Engine.image collection. As you know, the base of calculation is a list, but I want to have output as an image collection. That's why I need to bring the data inside the image collection format. So a Earth Engine.image collection, we will have a list starting with .map. So here for each list, we already have the start date. That's why the input of list is the date. So now I'm gonna calculate the end date based on the imported end date for each date we already have in the list. So here a new time start could be like the start date equals to Earth Engine.date. We already have the date information, but we don't have the end date equals to. Now we can calculate it using advanced function, just like that. That's advanced. Couple of arguments we have. From a start day, we want to go forward according to a delta. The delta is 1 day interval. That's why the delta stay will be 1 and the unit will be days, just like that, and skip the time zone. So here is start date and end date already defined. Just we must call all AOD data and filter them based on a start date and end date, or get and integrate all the data for each 24 hours according to our aggregated data based on each day and a statistical operator. For example, we can get the maximum of 24 hours or minimum of 24 hours or the average value, doesn't matter. It's totally up to you which kind of a statistical operator you want to use. For example, here I prefer to use the average one. Here I have a variable here. It is the IMG equals to, or the daily, or IMG or aggregates. IMG that is aggregated, or IMG that is created after aggregation. So we already have the AOD data, as you can see here. Get AOD here and then filter it based on start date and end date. Start date and end date. Now I suggest you to apply such kind of calculation in this step instead of doing the pre-processing at first and then convert the data to the daily format, because in this situation we will have higher speed of processing if we do the pre-processing while we are integrating data. So it is very important. If you want to apply this kind of calculation on each input data here before integration process, you must make a loop structure with a function as a IMG here. So as you can see, just I copy and paste the function calculation process just like that. As you can see here, it is calculated. Now we have it, and so here it is, and as you can see, yes, the scale factor applied. You can get rid of the previous one. And finally, after the data corrected based on the pre-processing step, you can get the average for each date, or you can get its average for every 24 hours. So finally, the function returning the aggregated image with a new system time start and system time end. That's it. Here we have system time start date, that's millisecond format, because the Earth engine uses millisecond structure for the time series analysis. And then again, that's set system time end date, that's millisecond. So if you want to have a new system index explaining the date of each image with a normal format, just make a new system index just like that, equals to a start date with normal formats, just like that, year, month, and day with a string structure. So now I'm gonna get a print here, remove the chart process, print AOD collection. Run a code. In the right panel, you will have an image collection with 365 elements. For each date, you can see we have one band that is AOD for 55, the optical depths 55 micrometer bands. That is already corrected using the scale factor we had, and also here in the system index you can see the day, month, and the year of each image with the corresponding system time start and system time end that help us for the time series analysis. So now I'm gonna make a chart to show you how AOD value changes during the time, because I'm gonna give you insight about the AOD variations during the time, and then show you how we can calculate the number of dusty days based on. So print user interface chart image.series. Couple of arguments we have. The first is the AOD collection. The region of interest is the geometry, and the reducer statistical aggregator should be average, or you can use any other statistical operator that you want to use. It's totally up to you. Earth engine dot reducer dot average, just like that. The scale 1000 meter, and X property equals to new system time start we already made here. Run a code again. In the right panel you will see a new chart that is generating. So here we have a chart is under generation. This time we actually we won't see any kind of 5,000 number of data or something like that, or errors related to the number of images, because we limited our data to the 500 to 365. So here, as you can see, we have a chart starting from 0 and also limiting to 2 that shows the AOD variations. As I mentioned earlier, there is a linear relationship between AOD and the dust we have in the atmosphere. As much as as much as the dust or aerosol increases, the AOD value also increases. The higher AOD, meaning the higher aerosol, the lower AOD, lower aerosol. And also when AOD goes beyond the 0.5, meaning that there is a dusty situation or there is a dust event there. And also there are some big events here, for example, in February 25, March 4, and also May 14 here. All of these could be considered as a dust event. In this image. So now I'm gonna show you how we can calculate the number of dusty days based on the threshold 0.5, for example, and then visualize it for the region of interest to see that which area experienced more dust events, or which area suffered more from the dust events, or which area suffered less from the dust events. And also it is a very useful spatio-temporal analysis in the Google Earth Engine that provided good facility that we have several good facilities for this purpose. And also I'm highly recommending to try with Earth Engine and use these capabilities to enrich your results for the further analysis and bringing a better insight for the audience. So let's see. Now here, make a new variable because we want to calculate the number of dusty days, dust events, or dust occurrence. So occurrence here equals to, or OCC. I prefer to use shorter and simpler names for the analysis because in that case you will have your speed of coding, and also the precision of your work will be higher. So OCC, or occurrence, equals to AOD collection already calculated here. And now I'm gonna actually make a loop structure to do this calculation for each image. Make a function here, each input AOD considered as an IMG. And now we must actually separate the dusty and non-dusty pixels through the threshold. The threshold here could be, for example, 0.5. So from each input image, I'm gonna select pixels in which the values greater than 0.5. So here, and then function returning the threshold without the properties of input images, just like that. So got sum here. As you can see, we have 365 elements imported to a loop structure. For each image or each element, pixels greater than 0.5 selected. And also here we have a binary image in which pixels greater than this threshold will have value number 1, and also pixels with less than this threshold labeled as 0 in the final data. So now we have 365 images, binary images, including 1 and 0 for each pixel. And when we get some of the images, you can see the number of dust events that each pixel experienced during this year. So here, let me to show you the final results through the map.add layer. Occurrence image already clipped based on the region of interest, and leave the visualization parameter empty. Just minimum value could be 0 because because we have 365 image, and also and all of them including 0 and 1, and the maximum will be no bigger than 365. So the maximum will be 365, and the layer name is occurrence. So here we must have a curve bracket, just like this, and use the false at the ends to avoid automatic visualization, and that's highly speed up processing in the Earth Engine platform. So remember to save your code and zoom into your region of interest. In the right panel, go to the layers, and here you will have occurrence image. Now we are waiting to see the number of dust occurrence for the region of interest. If the contrast is very low, as you can see here, you can increase it through the layer setting available here. So through the 90% of values in a histogram, I can increase the contrast, and once the range of data updated, you can click on apply, just like that, to see the number of times each pixel experienced the dust events. As you can see, we have a grayscale images from darker to a lighter region. The darker region shows less actually dust events compared to the bright region. As you can see, the white pixels shows actually the higher number of dust events. If you go to the inspector and click on a pixel, you will have a value here that shows how many times one pixel experienced the dust events. This is 20 times during a year. The AOD threshold was above actually 0.5 or dust experienced in this region. Or in this pixel, the value is 47, meaning that 47 times or 47 days during a year, the AOD was above the 0.5 or dust experienced in this region. So this is a very, very interesting kind of time series analysis with high resolution MODIS data for the aerosol optical depths or the dust monitoring. Most of the dust products suffering from coarse spatial resolution, but MODIS provided a good spatial resolution that allows us to do very nice spatiotemporal analysis in this regard. So, and most of you asking about the exporting data. So, for example, if you want to export from this product, it's very easy. Just you must use export that image to drive, just like that here, and couple of arguments we will have here. The first one is that image you want to get export. This is occurrence data already clicked based on the region of interest, just like that. And the description output name could be AOD occurrence, and a scale could be 1000 because the pixel size is 1000 meter. And the next is the region of interest, should be geometry. The next is CRC, coordinate system, should be EPSG 4326. This is a code that you can use for WGS84 that is same for all around the world. No need to change it based on the location. And remember that you can use this tutorial for all around the world. It is not limited to only one particular location. So feel free to use this code in your work and also for any other regions you are working, because the MODIS has a global coverage, and also the Google Earth Engine is available in all the countries. So there is no actually problem dealing with the Earth Engine and using this tutorial for all around the world. The next one is the target folder in which you want to save your data in. For example, I'm gonna make a test folder on my Google Drive, and then the output will be saved there. So now save your code. Remember to save your code and run it again. In the right panel, you will have a console. You will have in the task, you will have AOD occurrence image. Just click on run and again on run. Once the process of saving completed, the tabs color turns to the blue, and then you can go to the Google Drive and download the final result easily. So it is very, very simple and also applicable tutorial for AOD analysis or dust detection. So now imagine that I can plot the number of dusty days for each year separately, and also this could be very interesting type of tutorial. Imagine that we want to have a plot that shows how much actually the dusty areas changes from one year to another year. So it is very simple. Just we can make some very basic changes into the code, and also I think we don't have a lot of changes in the original code. Just you can change the time start and time end. For example, I change it to 2005 to 2015, 10 years I'm selecting here, And now I'm gonna have, for example, for each year separately, I'm gonna calculate the number of years, and here the time difference calculates the differences based on a year. Just print to see if it works right or not. Here, time difference, make a print. In the right panel, you can see 9.9. You can round it using the function .round. So it is rounded now. There it is, and run a code. So here we will have a list. You can check it you can check each line separately to make sure code working well. I'm making a list here, a list of 10 elements, and also, but this list is starting from January 2005 to January 10, 2005. Something is wrong. It is about actually the type of unit we are using. So we can make for example, a separate variable for the units. For example, I'm gonna change it to year. So, and in the code, whenever I'm using the units, meaning that it is year. And that helps you to avoid such kind of errors that may happen in your code. So here, starting from 2005, 6, 7 to 2014, but 2015 is missed in the code, and let me to remove the subtraction here, just like that. And here we will have 11 elements starting from 2005 to 2015, and now 2015 also included in our calculation. So here again, you will have AOD collection, then we are getting the list into a loop structure to calculate start and end date for each years. So here the units should be equal to the units instead of the days, because we want to update code based on a new unit we are using. And also here is the aggregation term, and here we are calculating, we are doing the pre-processing for each year separately. And also here you can also calculate the number of dusty days. Let me to make a new aggregation here, and the new one, a new ing aggregate equals to, we can use the same with a little change here. So let me to copy the previous aggregation process, paste it here, but this time with the little changes. So the aggregation started from each AOD we have. We're gonna filter our data from time start to the time end. So here in the body, make a variable as bands, a new variable as bands equals to, from input image, we want to do multiplication to the scale factor value, and then we will have a threshold from each band that is already corrected. I'm gonna select pixels greater than 0.5. Here the binary image created, and function is going to return the binary image, return the threshold. No need to properties of input images, you can get rid of them, just like that. And finally we want to calculate the sum of the binary images for each year. So as you can see here, the threshold returning by the function, and finally we get the sum of the binary images for each year separately. This is the same previous process, just here we are doing it in a loop structure. And finally, the aggregated data return with a new system time start and new system time end, and AOD collection, this time returning the average number of dusty days from 2005 to 2015. So here you can make a print to see how many data you will have in the AOD collection. So 11 elements available, and also each one of them is specified for 1 year. And also if you want to get rid of the zero band at the end, here I made a mistake before. Here the time difference should be removed from 1, because when you are using a start date and end date in the collection process, the image collection actually doesn't consider the end date value. For example, when you started from 2005 to 2015, by the end of 2014 considered by the code, and that's why if you want to consider 2015, you must go 1 year later, for example 2016. So here this time the problem is solved, and the last image is also for 2015, and the new chart that is creating showing the number of the average number of dusty days that we have for this region, particularly for a 10 years period. So this is a very helpful process that you can see how you can do different, how you can import such kind of analysis, you can bring it into a loop structure and making very interesting charts, informative about the monitoring of dust event for your region of interest. Typically, it takes a little longer and you must be patient. Remember to save your code, and also here you can see the number of dusty days trend, the average number of dusty days starting from 2005 to 2015. And as you can see here, in 2008 we had around 26 days on average, actually, the dusty days. And also, but in 2014 we only had 2 days as dusty days. So we say in this tutorial. So that's it's very helpful to monitor how much the number of dust activities or dusty days varies from 1 year to another year. I hope you liked this tutorial, and if you had any problem regarding to the code, I'm suggesting you to check my code. Its link is available below the video on my YouTube channel in the description box. And if you had any problem, you can reach me out on YouTube channel and put your comment there, and I will try to answer the questions as soon as possible. Thank you for your attention.